Okay, for example 2, we're going to graph and label FGHJ, the same FGHJ. All right, and let's see how good my memory is. We had 0, 3 for F, and 2, 4 for G, and 4, 2 for H, and negative 2, 0 for J. Is that right?
Yep.
All right. There's F, G, H, and J identified, and let me draw my lines again. So connect F to G, G to H, H to J, and J to F. And there's our quadrilateral again, F, G, H, J. This time we're going to be reflecting across the y-axis. All right, so notice, R, F, G, H, J, y-axis. So they're going to say this is R for reflection, this tells you what you're reflecting across, and this tells you what you're reflecting. So reflecting the quadrilateral F, G, H, J across the y-axis. So this time my mirror is going to be right here, and I want every point to reflect across the mirrors. That's not what I wanted. That's what I wanted. There we go. So, if you look at F, where's F? In relation to the mirror, where's F?
In the middle.
It's right on the mirror, right? So just like J before, J was on the mirror, it didn't move. F's on the mirror, it's not going to move. So this is F prime. All right? And then G is 2 spaces to the right of the mirror, so its reflection is going to be 2 spaces to the left of the mirror, so this is going to be G prime. H is 1, 2, 3, 4 to the right of the mirror, so its image is going to be 4 to the left. 1, 2, 3, 4 is going to be right here, H prime. Then J is 2 spaces left of the mirror, so its image is going to be 2 spaces right of the mirror. Unlike a real mirror, in geometry, the mirror can go right through a figure, so that means some points go on one side, some points go on the other side. That's just fine. It's allowed. All right, so if I connect the dots here with a straight line, F prime to G prime, G prime to H prime, H prime to J prime, and J prime to F prime. There's the reflection of the object. Again, since the mirror cut right through the object, that means some of the reflections on one side, some of the reflections on the other side. If we compare the points again between F, the pre-image, and F prime, the image, and so on and so forth, our original points were F was 0, 3, G was 2, 4, H was 4, 2, and J was negative 2, 0. F prime, looking at the picture, is 0, 3. G prime, looking at the picture, is 2 left, 4 up, so negative 2, 4. H prime is 4 left, 2 up, so negative 4, 2. And J prime is 2 right and 0 up or down, so 2, 0. We're going to do the same thing we did in example 1. We're going to compare the image points to the pre-image points, see what modification, what stayed the same, what changed, and make a conjecture based on that evidence. So, 0, 3 original became 0, 3 image. What happened?
They stayed the same.
Stayed the same. Nothing happened. All right, so same. All right, 2, 4 became negative 2, 4. What happened?
The x-axis.
The x number changed. So 2 changed to negative 2. The y numbers stayed the same. All right, if we start at 4, 2, and it becomes negative 4, 2, what changed? X changed again. 4 became negative 4, but y stayed the same. If we look at negative 2, 0 became positive 2, 0. X changed, y stayed the same. All right? And just like before, 0 and negative 0 mean the same thing, right? So officially, it doesn't look like it changed, but we could say that is negative 0 if we apply this idea. So looks like if we're reflecting across the y-axis, the y-coordinate is going to remain the same. The x-coordinate is going to change to its opposite. So the rule for reflection across the x-axis, we're gonna say the image point will be x comma negative y.
I thought it was negative X.
Oh, thank you. Image is gonna be negative x comma y. Backwards, negative x comma. So again, x changed, y stayed the same. So negative x, positive y. That's our rule for flipping across the, on this, that's what messed me up, I wrote x-axis here. There you go. The rule for reflection across the y-axis, y stays the same, x changes. All right, so going back to 1, x-axis, x stays the same, y changes, y-axis, y stays the same, x changes. So they're consistent at least. Whatever reflection is, that letter stays the same, the other one changes to its opposite. Tomorrow when we do reflections, we're going to have slanted line reflections. Those are more challenging. Okay, so you want to really get a good grasp on the horizontal, vertical line reflections right now. And again, anytime they talk about rigid transformations, the size and shape and all the angles and everything stay the same. They only change position. So you can see that these are identical shapes. They've been twisted, they've been reflected, but all the angles are the same. This angle here is the same as that angle there. The lengths of the side should be the same. So that's a rigid transformation. And when they talk about rigid transformation, that's all it is. Size and shape does not change.